Hello everyone, my name is Sai Teja. I am from CSIT. Uh, Today my topic is types of DC generator. DC generator. A DC generator is an electrical machine whose main function is to convert mechanical energy into electricity. When conductor slashes, magnetic flux and EMF will be generated based on the electromagnetic induction principle of Faraday's law. So we can see here the diagram. Types of DC generator is classified into two types: self-excited DC generator, separately excited DC generator. Self-excited DC generator classified into three types: shunt, series, compound. In compound DC generator are classified into two types: long shunt compound, short shunt compound. DC generators are classified based on how their fields are excited. There are three methods of excitation and thus three main types of DC generator. It's classified into three types: permanent magnet DC generators, field coils excited by permanent magnets, separately excited DC generators, field coils excited by some external source, self-excited DC generator, field coils excited by generator itself. Self-excited generators can further be classified depending on the position of their field coils. The three types of self-excited DC generators are series wound generators, shunt wound generators, compound wound generators. Permanent magnet DC generator: when the flux in the magnetic circuit is created through the use of permanent magnets, then it is known as a permanent magnet DC generator. It consists of an armature and one or several permanent magnets situated around the armature. This type of DC generator does not generate much power. As such, they are rarely found in industrial applications. They are normally used in small applications like dynamos in motorcycles. Separately excited DC generator: these are the generators whose field magnet are energized, ener- energized by some external DC source such as battery. A circuit diagram of separately DC generator is shown in the figure below. The symbols below are load, field, separate source of excitation. Here we can see the diagram of separately excited DC generator. IA equal to armature current, IL equal to load current, V equal to terminal voltage, EG equal to generated EMF, electromagnetic force, voltage drop in the armature equal to IA into RA. Then power generator is equal to, and power delivered to the external load is equal to self-excited DC generators. Self-excited DC generators are generators whose field magnets are energized by the current supplied by themselves. In these types of machines, field coils are internally connected with the armature. Due to residual magnetism. Some flux is always present the poles when the armature is rotated. Some EMF is induced, hence some induced current is produced. This small current flows through the field coil as well as the load and thereby strengthening the pole flux. As the pole flux strengthened, it will produce more armature EMF, which causes the further increase of current through the field. This increased field current further raises armature EMF, and this cumulative phenomenon continues until the excitation reaches the rated value. According to the position of field coil, self-excited DC generators may be classified as series wound generators, shunt wound generators, compound wound generators. Series wound generator. In these types of generator, the field windings are connected in series with the armature conductors as shown in the figure below. Whole current flows through the field coils as well as the load. A series field winding carries full load current. It is designed with relatively few turns of thick wire. The electrical resistance of series field winding is therefore very low, nearly 0.5 ohms, or SC equal to series winding resistance, ISC equal to current flowing through the series field, RA equal to armature resistance, IA equal to armature current, IL equal to load current, V equal to terminal voltage, EG equal to the generated EMF, then voltage across the load is equal to power generated. Here we can see the diagram of series wound generator. Shunt wound DC generators. In these types of DC generator, the field windings are connected in parallel with armature conductors as shown in the figure below. In shunt wound generators, the voltage in the field winding is same as the voltage across the terminal. Here RSH equal to shunt winding resistance, ISH equal to current flowing through the shunt field, RA equal to armature resistance, IA equal to armature current, IL equal to load current, V equal to terminal voltage, EG equal to generated EMF. Here we can see the diagram of shunt wound DC generators. A combination of these two types of generators can overcome the disadvantages of both. This combination of windings is called compound wound DC generator. Compound wound generators have both series field winding and shunt field winding. One winding is placed in series with the armature and the other is placed in parallel with the armature. These types of DC generators may be of two types: short shunt compound short, short shunt compound wound generator and long shunt compound wound generator. Short shunt compound wound DC generator. Short shunt compound wound DC generators are generators where only the shunt field winding is in parallel with the armature winding as shown in the given below. Series field current is equal to ISC equal to IL. Shunt field current is equal to ISH equal to V plus ISC RC by RSH. Armature current is equal to IA equal to ISH plus IL. Voltage across the load is equal to V equal to Eg minus IA RA by minus ISC or SC. Here we can see the diagram of short shunt compound wound generator. Long shunt compound wound generator. Long shunt compound wound generator or generators where the shunt field winding is in parallel with both series field and armature winding as shown in the figure below. Here the diagram of long shunt compound wound DC generator. Thank you. Thank you for listening.